Okay, and welcome back to the 2024 graphics paper. We're looking at question 3 now. A company sells a range of office supplies and equipment. So part A, shown below is a stapler. In the space provided, draw a well-proportioned freehand sketch of the elevation of the stapler, looking in the direction of arrow A. So it's the elevation they're looking for, not a 3D pictorial, and we're looking in from A. So we've a couple of different elements. So we have the blue base and we've got the red part and the grey part. So let's start with the blue base. Okay, so I'll just draw my horizontal line there for my base. And I'm going to have one side running up like that. Okay, so let's look at proportions. Okay, my height to width of that section is approximately the same. So let's say that distance, I'm going to step out approximately the same distance there. And then if we're to look at the distance from here, we have 1, 2, kind of 3 and a bit, 3.5 maybe portions. So that's 1 unit, 2 units, 3 units and a bit. Okay, so 1, 2, 3 and a bit. So maybe like that. So that'll be our full length of our base. Okay, that's the height. And then this section is about it's about 1/4 of the way up there. So about that height. Okay, so I have that outline and now I just need to draw it in. Okay, so that's the base, right? Then we've got our red element. Now we're not going to know the angle, but we know it's coming from here. We'll do something kind of like, maybe, yeah, that angle I'm kind of happy enough with. So up there lightly, just to see what it looks like, right? If you imagine that rotating down, yeah, so about there. We want to go at 90 degrees to that. If we look, it doesn't go back to that corner, it goes a little bit below it. So about that height down, so that height down. And we're going to run parallel. And then it looks like it goes back in a little bit, so back in a little bit. And we'll have our same portion. Parallel line there again. Okay, let me just go over that a little bit heavier then. So just good to get our proportions correct there. And that looks like a fair representation of our elevation looking in from A. So part B then, the image shows a push pin supplied by the company. So our little push pin for hanging notices. Shown below is an outline drawing of a similar push pin. So we've got our drawing here. Redraw the push pin below, rotated anti-clockwise about point O. So point O is our center of our rotation. And we're rotating it anti-clockwise, so down that way. Until A reaches the line LL1. So until A rotates down and reaches LL1. So we'll get our compass, we're going to need that, and I'm going to label my points. So I've got point A, B, C, D, E, F, and will we need G? Probably do, G. Okay, so O is my center of rotation, point A. We're going to rotate A down until it reaches LL1. F is actually in line with that as well. So rotate that at the same time. G is somewhere down there. B and E will also be in line with each other. So I can rotate 2 of those down together. And C and D will also be in line with each other, so rotate those down too. Okay, So all of those points have been rotated down. The only one we've found the new version of here is A. That's A1. Because it said let's rotate A down until it touches LL1, which it has. So next up, we're going to say that the distance from A to F isn't going to change when it moves down here. Same with the distance from A to B, it's not going to change. So let's start with A to B. So A to B from here, that's my new B. A to C. Okay, so if I do A to C, probably will work if we've got a nice sharp compass lead, but well, it'll be easier to see exactly that point if we actually have something crossing the arc a little bit better. So I'll leave that one for now. Same with D. So let's go and find F. So F from point A, that finds me F. So I've got B1, F1. Okay, now from F I should be able to find points that will give me a bit of a better arc. So for E, there's my point E. For C, there's my point C. And D, there's my point D. Okay, so let's label them so we don't confuse ourselves. E1, D1, C1. Right, the only point we haven't found is G, but if I draw A across to F, it should pick up point G. So A joins to B. B to C. So join up all our points. Okay, so that one's not fully clear, so I'll actually get the distance for G there from A, and I'll swing it from A. There I have it. So now I can join that to O. So that was my point G1. Okay, so that's my object rotated. Okay, now we are going to go here to point question C. So the image below shows the design for a binder clip. Okay, so here's our binder clip. The clip includes a parabola DOC. So DOC with vertex O. So O is our turning point, that's our vertex. Draw the parabola DOC in the rectangle ABCD across. So here's our rectangle and we want to draw our parabola fitting into it. So we need to divide our lines into equal parts. Let me just see, is there a measurement on that? Okay, that's not really a useful measurement. And neither is that. So we'll divide it into equal parts. So I'm going to come up here from A, draw a line at any angle. From O, we'll draw a line out there at any angle. Okay, so we'll start with the top element. I'm going to divide it up into, say, 4 equal parts. That should do us, maybe even 5 equal parts. Go just to make it a little bit more accurate because it is quite tall there. 1, 2, 3, 4, 5. Okay, now we're going to join point back. So those are not in line with each other. Okay, if they are, that's just a coincidence. Okay, so I'm divided 1, 2, 3, 4, 5. What we're going to do then is slide in set squares to get parallel lines. So, kind of tricky with the fold on the page there. So that angle, I'm going to slide back and find 4, 3, 2, 1. Okay, so that's divided this into equal parts, and this side we want to go parallel to our axis down the middle. So I'll draw that now before I do any more. Okay, so that's that one done. We're going to do this side then. We need to divide this also into 5 equal parts. So we'll go 1, 2, 3, 4, 5. So I've got 1, 2, 3, 4, 5. And we join that last point back to the other end of the line. And now we'll use sliding set squares. So slide up, parallel line, slide up, parallel line, and continue on. Okay, so key mistake here is people will draw a line straight across. That is not what we're looking for. We want to join this side AD, all these points up to the vertex. So from 1 up to the vertex. So that first point passes that first one, so that's going to be our point. We'll repeat that down along. Okay, second point. So there's our points. Okay, now we could repeat all that on this side again, or we can use axial symmetry. So no harm in doing axial symmetry. So that point, it'll be the same distance there across because it's a mirror image. Okay. So I'll get the distance from my axis to this point, swing it across. Next point up, swing it across. Okay, and now I can draw my freehand curve, a nice gradual curve at the top. Looking at the point I'm traveling to. And same on the opposite side. Okay, so there's my parabola. Is there anything else asked there? No, no coloring or anything, so we're good. Then, question D. The image across shows a pen holder. Shown below is the plan and incomplete elevation of a similar pen holder. So part 1, fill in the missing word in the sentence below. The pen holder is a truncated, square-based, and the answer there will be a prism. Okay, so if you imagine the full shape, if it wasn't truncated, means it's been sliced or a chunk taken out of it. Okay, square-based, it's got a square base. If I was to do X-ray vision there, I can see it's a square. That's a prism going up. So prism. Part 2, complete the elevation of the pen holder from the given plan. So they've shown us part of it. We just need to finish this off. So that's one point. That's the height of the next one. Check that up and project that up. Okay, so this edge is here, so I can draw that out. This edge is here. That's the height of it. I can join those two up and draw this down. And don't forget to have your heavy line for your base. You need to complete that line. Last bit then, ask yourself, is there any hidden detail? There is. At this back edge, I've got hidden detail. So a dashed line running down there, like so. So that's part 2 completed. Very last part of this page, question 3 then, is find the true shape of surface S. Right, so I'm just going to highlight surface S here. Okay, and that's surface S. So surface S is at an angle. Okay, so we need to, in this view, so we need to find the true shape of that. There's 2 methods. Okay, the first method is rotation. So I'm going to rotate that plane or that surface around. So here it is. I'm going to rotate it around to here until it's in a new position, whereby when I'm looking directly at it, perpendicular to it, I'll see its true shape. So that's it rotated in plan, and we'll find it in elevation. So that edge is there. That's the height of that edge, so the height hasn't changed. Okay. This is that line there, and it's rotated around that edge. So here we have true shape using rotation. Okay, so that's the true shape there. Okay, so second method we have then is auxiliary views. Okay, so we want to do an auxiliary elevation over here showing that surface, looking directly at it. Okay, let me just check, have we got this at a nice angle? Yeah, so usually I'll try and do this something like this for us. So that is the surface I'm looking at. I want to look directly at it. So my x1, y1 line is parallel. So that's my x1, y1. I have projection lines then going out perpendicular. Right, so perpendicular to my x1, y1. I'm creating an auxiliary elevation. Okay, elevations have the same heights, so the same height here would be the same height here. So if we go through it, we have a point and a point. So that point has 0 height. That point has 0 height. This line then is that height, and if I follow it down and up, it'll be there. And this line has this height. So I follow it down and up. There we have it. So now I can draw in my heavy edge, heavy edge, heavy edge. So that is also my true shape of surface S. So 2 methods, okay? You can just do the rotation method, or you can do the auxiliary method. Both will get you full marks, but you only are required to do one or the other. Okay, so that brings us to the end of question 3, 2024.